Okay, here are the answers to the problem set on linear momentum. You have to find the force, so use the two equations for impulse. Set them equal to each other. Remember that the objects are moving in opposite directions. So if you take one as positive, the other must be negative. So 4,398 newtons is the answer. In number 2, that's the mass. The first one, velocity, this or the first, and mass of the second, velocity of the second, and they're both moving in the same direction. Not only that, the cornerback actually latches on to the halfback, so they move together after the collision. Therefore, they are one object, their masses are added together, and they have a common velocity. And it turns out to be 4.76 meter per second. In number 3, the boxcar is open, which is one. No, this is where it impinges on a second one at rest. So the velocity of the second one is 0, and you got to find the mass of the second car. Again, they stick together. Therefore, they have the same velocity, and that is 6 meters per second. Apply the conservation of momentum. Carefully substitute the numbers. And the answer is 13,950 kilograms. Question 4. 3,800 kilogram open railroad car. Snow is falling into it at 3.5 kilograms per minute. No friction. And therefore, after 90 minutes, the total amount of snow that has been falling is 90 multiplied by 3.5, which is 315 kilograms. So the mass of the railroad car increases by that amount. So its new mass is 3,800 plus 315, and then apply the conservation of momentum. And that's the answer. In number 5, 23-gram bullet. Change it into kilograms. And that's moving at 230 meters per second. Mass of the block 2 kilograms, and initially it is at rest. After the collision, the bullet comes out at 170 meters per second. Again, a simple case of conservation of momentum. .69 meters per second. In number 6, has to find the impulse. An impulse is force multiplied by time, or it is the change in momentum. They're using the second equation, the mass of the ball times the final velocity minus the initial is 0. So you get 2.025 Newton second. And then to find the force, use the other equation, that is force times time. And calculate the force. In question 7, that's the mass of the car, which is 1500 kilograms, and its velocity is 50 kilometers per hour. Change it into meter per second. The final velocity is 0 because it crashes into something really massive. The time of impact is 0.15 seconds. So again, set the two equations for impulse equal to each other to find the force. Plug in the numbers carefully to get the answer. And to find the force, to find the deceleration, use force divided by mass. Should be negative because it's slowing down. And the force is also negative because it's an opposing force. Number 8. The two balls have the same mass, and their velocities are 2 meters per second and 3 meters per second, and that's in the opposite direction, so it's -3. You have to find VA prime and VB prime. And because it's a perfectly elastic collision, we can use this equation. Remember, it can only be used if it is a perfectly elastic collision. That gives us one equation. And then you can use the conservation of momentum to get the second equation. All the masses will cancel out. That's equation 2 now. Solve 1 and 2. I'm adding equation 1 to 2. So that's why 5 minus 1. It's actually 5 plus minus 1, which became 4. And the right hand side becomes 2 VB prime. So you get VB prime as 2 and VA prime as negative 3. And you see that their velocities have been interchanged or reversed. Question 9. Simple case of conservation of momentum again. And here again it says it is an elastic collision. Therefore, once again you can use this equation. And then use the conservation of momentum in order to get the second equation. Now in place of VB prime you can substitute open the parenthesis, and you get the velocities. Number 10, it's an interesting question here. You have a pendulum hanging down like that, 3.6 kilograms, and a bullet is fired right into it, making it swing up. X is the horizontal displacement, Y is the vertical displacement. Initially the block is at rest, that's why VB is 0, and after the collision they go together, so VA prime is equal to VB prime. So they become one object. Their masses are added together and you calculate the velocity. And then use the fact that the kinetic energy at A becomes the potential energy at B. Because as the pendulum swings up, all its kinetic energy gets converted into potential energy. And that gives you the vertical displacement Y. And then the length of the pendulum minus the vertical displacement gives you that length, actually this length, as 2.64, and we know that this is 2.8. Therefore, you can find AB. We can do this because it's a right angle triangle. In the 11th question, that's the mass of the sports car. We need to find its velocity. Mass of the second one, the SUV, 2300. And it was not moving because it was stopped at a red light. Okay. Now what stopped them after the collision was friction. And friction is mu times Fn. And because it's a level road, Fn is the mass times g, which is the mass of both the cars together times g. So you get friction as that much, and so you can find the deceleration using the force of friction by the mass. Which gives 7.84 meter per second squared. Actually negative because it's slowing down. And then you can work backwards because the displacement is given and the final velocity was 0. You can find the initial using this equation from chapter 2. And after you get the velocity, remember that 6.63 meter per second was the combined velocity with which both the cars began to skid forward. So now you have to apply the conservation of momentum to work back and find the velocity of the sports car. As 23.19 meter per second. In number 12, the two eagles are moving at right angles to each other. And all you got to do is find the resultant. We call them A and B. The momentum of A is of course the mass multiplied by the velocity. Gives 33.5 kilogram meter per second. And likewise the momentum of B $57.1. To find the resultant, just square root of the sum of the squares of both of them. And to find the velocity, just know that the resultant momentum is the mass multiplied by the velocity. So add up the masses and find the velocity, 6.7 meter per second. To find the angle, the tan theta is opposite by adjacent, so it's 57.1 divided by 33.5. 1.70, take the arc tangent of that to give 59.6 degrees. And question 13, it's a problem about center of mass. Those are the positions of the cars, each of mass 1200 kilogram. And right here you have the center of the raft, and so the 6800 kilogram can be imagined to be acting right through that point, through the center. Set up a coordinate system with that point as the origin, and then use the formula for calculation of the center of mass. The first one obviously becomes 0 because the origin is exactly right at that point, so distance is 0. Remember, every distance is measured from that point. 1200 times 18, okay. Now I'm showing each term. Next one, 1200 times 18 root 2, which is that one, plus 6800 times 9 root 2 divided by the sum of all the masses. Comes out to be 7.78 meter from the southwest. In question 14, the man and the woman, 10 meter apart. Man 80 kilograms and the woman 55. So let's say the center of mass is x meters from the man. So it should be 10 minus x from the woman. Therefore, R is 80 times x. That's because we've set up the origin at the position of the man. So all distances are measured from the position of the man. Oh no, now I'm taking the origin at the center of mass, therefore that is why the backward distance must be negative. I'm sorry for that. And then you could have taken it either way. So if you take it at the center of mass, this distance becomes negative and this becomes positive. Calculated as 4.07 meter from the man. And then the B part, the man pulls on the rope, he moves 2.5 meter. Says how far from the woman will he be now? So if the 80 kilogram man moves 2.5, the 55 moves x. Which is 3.64. And then in the C part, how far will the man move when he collides with the woman? Know that the ratio of the masses must be reverse of the ratio of distance moved, which is what I'm writing now. You just notice that it's reversed because the heavier one will move a smaller distance. So I get the ratio as 0.69. And then you know that the total distance between them was 10. So both of them together should have moved 10 meters. And therefore the man should have moved 4.1 meters. 15. Simple question where the two of them, 60 kilograms and 80 kilograms, are at rest. And they push apart like we did before. M1 times R1 is M2 times R2. And therefore the distance moved by the lighter one is, in fact the distance moved by the heavier one is 9 meters. For the total distance apart is 12 plus 9, 21 meters. 16. Interesting question. Those are the two situations that I've drawn. First you have the 60 kilogram person and the 75 at the two ends, and then they switch the ends, which makes the boat move through. So the boat moves through a distance. That's messed up. Okay, again. The boat moves through a distance d. And that is the calculation of the center of mass in the original situation. Which gives it as 1.71 meter. But now since the boat has moved out by t, and you know that the center of mass cannot move because there's no external force, when they move, when they switch the ends, it's just an internal force. That is why the center of mass is still 1.7 meter, 71 meter away. So 75 times d. Just look at it carefully. You'll see it's 75 times d here. You know, times 80 plus 80 times 1.6 plus d. So you just add the d to each distance because that's how much the boat has moved. And make the calculations. And the boat has moved 0.22 meter. And in question 17, the alpha particle comes out of the atomic nucleus. And you're asked to find the speed. And if the mass of the alpha particle is taken as m, the question says that the nucleus has a mass 57 times greater. That's why it's 57 times m. And according to the conservation of momentum, the two momentas must be equal. Okay, therefore, the velocity of recoil is 6.67 times 10 to the 3 meter per second. And in the last question, the skeet is fired at an angle of 30 degrees to the horizon, and when it reaches the maximum height, let's say that's where the skeet is, when it reaches the maximum height, it's hit from below by a 15-gram pellet traveling vertically upward. So now it's going vertically upward at 200 meters per second. Okay, so that's the representation of the momentum of the skeet is its mass times its velocity, and the pellet is wait a minute. The velocity of the skeet was actually 25 meters per second, so I messed up. Oh, I have to change all the calculations now. So that's going to be 0.25 times 25, which is, I believe, 6.25 kilogram meter per second. Okay, so I have to change all of those. And the pellet is 3 kilogram meter per second. Okay. Now what is to be done here is you have to resolve the velocity well, I had to correct for a silly mistake that I made. Now, resolving the momentum of the skeet, you get the horizontal as 5.41 and the vertical as 3.125. So when you take the total horizontal component along the x, there's only one, 5.41, but along the y you have the momentum of the pellet plus the component, the vertical component of the skeet, its momentum. So you get a total of 6.125. And to find the resultant, you have to square them up, add and take the square root, which gives you 8.17 kilogram meter per second. And now to find the velocity with which both of them move up, you divide the momentum by the mass. Mass in the sense the total mass. So that gives 30.83. That's the velocity with which both of them begin moving up. And therefore, as it moves up, its kinetic energy gets converted into potential. They must be equal, the masses are cancelled. And you can get the height that it would go up above the maximum height. So you get it as 48.5 meters. Thank you.